Hello, Tom again. In this stage of the exercise, what we're going to do is we're going to add three more classes to the vehicle classes class library. So we're going to create a new class called train, which is going to be based on the vehicle class. Train will also be an abstract class, meaning when we eventually create train objects, they won't be just generic trains, but rather they'll be a specific type of train. Okay, so again, abstract. The only property that we're going to add to the train class is track gauge. So that's the type of track that the train is compatible with. Now again, I could be adding a whole pile of other properties that would be appropriate to this class, but for the purposes of this example, this one will do fine. Okay. In terms of method, we're going to override the toString method, similar to how we did that in the other classes, and of course we'll have a constructor as well. Now from the train abstract class, we'll derive two other classes, a passenger train class, which is obviously a train that carries passengers, similar to a car. It has a passenger capacity and passenger load, which we'll have fields and properties for, and a freight train, which similar to a truck is a train that carries cargo. So we have appropriate fields and properties to handle that. In both cases, we have constructors and overloaded toString methods. And of course, like the train class, we would have other properties and methods as appropriate to the class. But for this example, it's fine. You'll notice that the passenger train is going to support the iPassenger carrier interface that we defined in the last group of videos. Okay, so this is our task. Now, in terms of the track gauge inside of the train class, that's based on an enumeration. So I think we'll probably start there. I just want to define what this enumeration is to begin with. All right, so I've just made Solution Explorer a little bit bigger here, and in the vehicle classes project, I'm going to add, again, you don't see this, but I'm choosing a component again. Okay. Enumeration, is enumeration even in here? Probably not. I can just add a class and then change it. So this .cs file, let's call it track gauges. Okay, so track gauges.cs and then add. All right, so we've got our, right now it's a class, but we're going to change that to a public enumeration called track gauges. I'll add a comment at the top, and of course you can put your name and stuff on it, and I will get rid of the usings that I'm not using. All right. Okay, so in terms of the actual enumeration itself, let's start off with a comment for that. So I'm just giving a quick summary of what it's supposed to represent, different track gauge options. A little bit of a remark here in case you don't know what a track gauge is. It's the spacing of the rails on a railway track measured between the interfaces of the load, blah, 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 blah. That's what a track gauge is. So you can look at that. And of course, if you're not too familiar with that, I've got a Wikipedia entry as well you can check out, but it's not necessarily hugely important. Now, there are lots and lots and lots of different track gauges. I'm going to just define maybe 4 of them for the purposes of this example. Okay. All right. So I'm not an expert on trains or electric cars or anything along those lines, as it might seem evident in the video. But at any rate, I've defined these 4. There's the minimum size, which corresponds to 381 millimeters. So I'm making use of not only the enumerator, name, which I can convert to a string, but also its underlying value. Okay, so the value of the track gauges enumeration also has meaning. So minimum, narrow, standard, and broad, the various different measurements. Okay, so we'll go ahead and save that. And then next up, let's look at our train class. So once again, our plan for the train class, it's an abstract class, inherits from vehicle. Its singular property is track gauge, and it has a toString and a constructor method. So let's add the class. I'm going to call it train. Oops, I named it .ca there. I have to correct that, and correct that in Solution Explorer there. There we go, that's better. We'll start off with a comment and, oops, start off with a comment and clean up the usings. So you can again put your own name in there. We'll add a summary tag here for the train class. So I'm saying the train class serves as a base for other classes that represent different kinds of trains. This class is abstract and it's going to inherit vehicle. So let's deal with that. So first off, it's a public class. It's an abstract class. And it's called train and it inherits vehicle. Okay, so that sets up the actual class. All right, let's deal with the property. Okay, so I'm going to be using just a very simple automatic property because there's not really a lot of validation to worry about. So I'll add that. You may want to pause the video to get caught up. So a little summary tag, automatic property to set, get, and store the track gauge of a train. And that's all I have to do to set that up. Next, I'm gonna actually code this above this one. I'm gonna deal with a constructor. Okay, so our constructor needs to set not only the track gauge, but also all the default or all the other properties and fields, etc., and so on that we inherit from the vehicle class. So I'm going to use the constructors that I had in the other classes as a pattern. Again, you may want to pause to get this caught up. So let me just put that in there. Make this a little bit wider so you can read a little bit more of the comments. All right, and again, you can pause the video if you need to. Perhaps I'll just temporarily put a little new line there so you can see all of the code. So the first parameter is a track gauges enumeration called track gauge, which defaults to the standard track gauge. And then the rest are basically in the same order that we had them in for other vehicles. Again, I call my base class constructor the vehicle constructor, and I send it the 3 different things it needs to initialize the vehicle portion, and then all I'm left with is initializing the track gauge property. All right, and the final thing to do with the train class is to override the toString method. Okay, and again, I'm just recommend that you use the other classes as a guide. So here's my solution. Again, start off with some commenting and documentation. Internally, I'm defining a string and a width. I'm using 25 pretty consistently throughout. I take my string and using string format the track gauge the exact way I want, and I'll just temporarily put a new line there so you can see the end of the line. Okay, so I'm inserting the track gauge like literally in a field width of 25. Followed by the track gauge to string, so it's going to say standard or minimum or whatever, followed by in brackets the track gauge typecast as an integer. So that's what I'm going to see there. Now for the rest of the toString, I just want to basically see what let the vehicle version of toString to take over, and then of course I return it. So let's do some quick testing of the train class. I'm going to go back into the console application and we'll make some modifications. All right, just to keep things clear, I'm going to comment out basically all of the stuff I was doing before with the cars and the trucks. So I can put it back in a little bit later on if I want, but I'm just going to comment all of those lines out to keep this clear. So of course I don't have test object declared anymore. So once we go through all that, here in your source code, you'll notice you have these 2 commented out lines, including passenger train test object. A little mistake in the file there. What I want you to do is uncomment that line and change it from passenger train. We'll change it back a little bit later on once we have a passenger train class. But okay, so train test object equals new train. Now you'll notice that won't actually work. The reason why it won't work is because train is an abstract class, so it's not allowing us to actually create a train object. Now I still want to see if this works, so I'm going to scroll up to the top here, and I told you to sort of shrink this down before. I've actually got a temporary little class here. Right now it's called inherit test, and it inherits from vehicle. What I'm going to do is I'm going to change that to inheriting from train. So because train is an abstract class, I can't create objects from it, but I can use it as a base class for inheritance. So this temporary throwaway class that doesn't really do anything, all it's doing is testing to see if I can actually inherit from train. So then in my main, I'm going to go down. I'm going to, comment that line again, and on the line above, I'm actually going to create an inherit test object. Okay, and we'll see if that works. Now, you'll notice that I don't have any errors on that line, but I still have an error on this line for my interface-based polymorphism. I can't move people a random distance with this test object because this test object is not necessarily a people carrier. So I'm going to comment that out for now. Okay, so I'm going to go ahead and run that. And what I can see is that I'm obviously getting some train stuff. Okay, so we'll expand on this. Next up, we'll deal with the two different child classes of train, which is freight train and passenger train. We'll deal with that in the next video.